So this video is to help people with our lesson on 9.2, number 27 and 42 questions are popping up. So here is number 27. If you look on page 472, either electronically or in your textbooks, you're going to find these two equations. S equals r theta. S is the arc length. So in our problem over here, the arc length would be this piece on the curve right here. R is the radius, so our radius on the problem we're looking at looks like 10 yards. The radius is the same from the center out to any point on the circle. And theta is given in radians. Now that's where it's probably getting some people here. So notice over in our problem, we have 90 degrees is given to us, and that's our theta angle. But if we're going to use these formulas over here, our theta has to be in radians. So this is where your unit circle comes back. If I have a circle, here's my unit circle, oops. And I know 90 degrees is right up here, straight up top. The radian measure for that, if you spend your time memorizing, you know it's pi over 2. If you didn't spend your time memorizing, you're going to go 90 degrees. You're going to do that unit multiplier. We want the degrees to go away, so we want degrees on the bottom. And the fraction is either pi over 180 or 180 over pi. In this case, we're using the pi over 180. The degrees are going to cancel. 90 and 180 are going to reduce. 90 divided by 90 is 1. That leaves the pi on the top, excuse me. Sorry. And 180 divided by 90 is 2, so that's where the pi over 2 is coming from. So then this problem asks us to find the length of the safety rail and the area of the deck. So notice we have two different answer boxes down here. So if we want to find the length of the safety rail, that's this part right here that I just got to change to green. People actually do this. They build decks like this. Maybe you can someday. If I want to find the length of the sector is that S value. So I'm going to grab my formula. S equals r theta. I don't know S, so it stays. My radius, I know from the picture, is our 10 degrees right here. Not 10 degrees, 10 yards. And our theta in radians is pi over 2. So if I want to use my fractions, I can reduce and I can get 5 pi. And that should be my answer here. But, oh, another twist. Let's go new color here. It says we want to round our answers to the nearest tenth. So you need to go to Desmos. And you're going to put that 5 pi in Desmos or a calculator and get me a decimal answer and round it off. The area of the deck in square yards, the second part here, we've got our formula. Area is 1/2 the radius squared times theta. So I'm going to use that formula down here. I'm going to find my area. So I'm going to keep the 1/2. The radius we know is 10. From back up here in the picture, here's our radius, still 10. And then we're going to put in our theta, which we now know needs to be, oh, don't forget the squared, needs to be pi over 2. So that's going to give me, on that, let's just do this, it's all fractions. The top I've got 10 times 10 times pi. The bottom I've got 2 times the one that's under the 10 times 2. We can reduce the 2 with the 10 and make it a 5, reduce the 2 with the 10 and make it a 5. So now I'm going to have 5 times 5 on the top is 25 pi over the one that's left on the bottom. But then you're going to convert to a decimal using Desmos and then enter that in. All right, so there is 27. Now watch that radians. Here's 42. Same thing happening here. The measure of theta. We know, and notice down here, oops, we're finding theta, and down here next to the box, it says theta is measured in radians. So I'm going to use my formula. Arc length is the radius times theta in radians. which is good because that's what we want. We're going to do what we know, plug in what we know. Our arc length is this 4 up here, so I'm going to put my 4 in for my arc length. My radius they gave to me in the diagram right here. The radius is 4. I'm going to put my 4 in here for my radius. Theta, I don't know. Theta is just a variable. I don't want my theta divided by 4, so I'm going to use my algebra, divide both sides by 4, and my theta looks like is exactly 1 radian. That's the end. Happy times.